Hi, microbe folks. We're on fermentation day 2. You'll recall that we looked at grape and blueberry fermentation. We're still in the process of growing the microbes and analyzing them. And again, folks, going through my refrigerator, I found a bag of chopped cabbage and carrots, and it said best by May 23rd, and today is June 4th, so we're almost 2 weeks overdue. So I was like, I probably don't want to eat this, but I said, oh, we could ferment it though. And what's so neat, you guys, I wanted to see if we could do a lactic acid fermentation, which is the classic way to make sauerkraut, literally sour cabbage, kimchi. You can make pickles with it. And you might all know, if you were to compare the fresh vegetable to the fermented lactic acid fermented vegetable, the lactic acid fermented vegetable tastes sour. That's how we detect a high concentration of hydrogen ions, right? So by carrying out lactic acid fermentation, the microbes take the sugars in the plant and converts them into lactic acid. So that's what we're detecting, is that sour tasting lactic acid. And just as we said for alcoholic fermentation, where the alcohol inhibits or kills spoilage microbes, low pH, that really low pH, around maybe pH 4 or 3, that too will inhibit the growth of spoilage microbes. So lactic acid fermentation was a way, well, another way for our ancestors, and today as well, that our ancestors could preserve foods in the absence of refrigeration. And again, often, you're only able to grow your vegetables, say, in summer and harvest in fall. So you had to somehow preserve them to get you through sometimes those long, cold winters. Well, when I opened up the sack, you guys, it was kind of fun. I took a whiff, and oh my gosh, there's already lactic acid fermentation going on in here. I can smell that kind of pungent smell of the lactic acid. If any of you have been around farms where they make silage, silage is a way to preserve grass for cattle, say, again using lactic acid fermentation. So it has this distinct, wonderful aroma. Or if you've ever had sauerkraut, open up a jar of sauerkraut, there's this wonderful, wonderful lactic acid smell that comes out. Or kimchi, right? So in some ways, you guys, it's like, well, that kind of ruined the experiment because the lactic acid bacteria got ahead of me. But what I thought we could do, when I was growing up, my dad would show me how to make sauerkraut. And what we would do is we'd get clean mason jars, and my dad taught me that you put in a layer of cabbage and then you sprinkle some salt on it and you pound the salt and the cabbage together, and it makes the cabbage juices come out, and you're pounding it really hard, filling it all the way up to the top with alternating salt and cabbage. And now, as a microbiologist, I think I get a little bit what's going on, because remember, you guys, with fermentation, anaerobic, no oxygen conditions will encourage microbes to switch over from, say, aerobic respiration to lactic acid fermentation. So what we are doing in adding the salt, and the salt can inhibit some spoilage microbes, but by adding the salt, we are also encouraging the efflux of water juice from the plant cells. And then by pounding it, again, that was another way to get rid of the air. So we're creating this nice anaerobic environment inside the jar. Well, this bag was basically, when it got packed, it wasn't anaerobic, but it was sealed tightly, and so potentially it did go anaerobic in here. And furthermore, you guys, the lactic acid bacteria, they can't use oxygen in aerobic respiration, but they're not killed by it, right? So our lactic acid bacteria, no matter what, if air is present or not present, they're going to do the lactic acid fermentation. The lack of oxygen just maybe helps prevent some spoilage microbes that maybe do use aerobic respiration from growing. All right, so you guys, so what's this experiment about? We'll do another one. We'll try to do another cabbage experiment here, you guys. But what I just thought, we could take this cabbage, so it's already lactic acid, bacteria are starting to work on it, and we'll just see if adding salt makes any difference. So this, instead of a mason jar, which would be ideal, I have my little cabbage bags here. So what I'm going to do, let me see here. Let's do two. Let's see here. Do I want to do salt? Let's do anaerobic on both of these. So I'm going to change the label, you guys. I was going to have a four-way variables, but I think what we're going to do is let's add salt to both of these, and So I'm going to add, this is probably around, maybe guys, around 6 ounces. I'm going to add a teaspoon of salt. Okay, and what I'm going to do is I'm going to let this bag, I'm going to munch it up, like get those juices going, and I'm going to seal it to try to keep it anaerobic. And then the other bag, I will also add salt to it, but I'm gonna have the seal be loose, so it will be aerobic. So I'm just curious to see if keeping the cabbage anaerobic, will that have an impact on the fermentation if salt is present, right? And what we'll do, you guys, next time I'll get some fresh cabbage and we'll run. And I'm so sorry, I forget how loud this crackling sound is right next to the microphone. I apologize. The next cabbage experiment we'll do an aerobic no salt, an anaerobic no salt, and then an aerobic salt and an anaerobic salt, and see if any of those variables, like by eliminating the salt or by permitting oxygen in, is one of those treatments, will the cabbage more likely spoil, right? So we're not inhibiting the spoilage microbes, or does it not matter at all? It's kind of fun. Okay, so again, folks, I'll stop. I will stop crackling the bag. So this one, I'm going to continue to kind of work the cabbage to get some of the juices out, and then I'm going to roll it and seal it, try to keep it anaerobic. The other one, I'll do the same thing. I'll try to massage the cabbage, get some of the juices out, but I'm not going to seal it tightly, so the oxygen will be able to penetrate. And I'll probably just stick them here in the garage, you guys, and we'll just check them every day. I'll try to pH it here at the start, and then each day we can pH it to give us an idea if maybe some of that lactic acid is being produced or not. Okay, so that was a real short one. Just so much fun, you guys, with lactic acid fermentation in foods. Just a lot of fun. Okay, we'll see you with the next video.